Okay, today we're going to talk about the unit circle. So back in geometry, you learned this acronym to help you figure out which trig ratio to use. So for sine, we're dealing with opposite and hypotenuse of the angle. So here we would have opposite, and here we have the hypotenuse, right? And for cosine, so this is for sine theta, we're dealing with opposite and hypotenuse. And for cosine theta, we're dealing with adjacent over hypotenuse. Opposite over. Okay, so sine theta is opposite over hypotenuse, cosine is adjacent over hypotenuse. Okay, and the adjacent side is this guy here. Now, one thing to think about is adjacent is, this is the length in the x direction, right? Okay, so first of all, let's think of the special case when the hypotenuse length, when this line, what if this is equal to 1? Then if the hypotenuse is equal to 1, then I have sine theta equals opposite over 1. So if I have sine theta equals the opposite side over 1, then that's going to be equal to the opposite side, right? And same thing with cosine. If cosine theta is, if h is equal to 1, then it's going to be simply equal to the adjacent side. Okay, so how is this and why is this important? So the adjacent side is the direction. So let's say I've got a unit circle, and every point on here, this length here is 1. So here we've got 1, 0. Here we've got 0, 1. And everywhere on the edge of the circle is the radius is 1. Okay. We've got -1, 0, 0, -1, and so on. So this distance, and I've got some arbitrary point right here. Okay. The distance traveled in the x direction is going to be, the distance traveled in the x direction can be, oh shoot, I did the wrong color, can be cosine. And the distance traveled in the y direction can be sine. Because the opposite side from, let's just draw a triangle right here. From this angle theta, the opposite side is sine. And the adjacent side, the yellow side here, is equal to cosine. So this coordinate here is actually could be equal to, the x value is cosine theta, and the y value is sine theta. You might need to hit pause and replay this again. Okay, so let's think about the unit circle. There are 3 important points that are normally talked about in pre-calculus: 30 degrees, 45 degrees, and 60 degrees. So we can use a calculator to get these, and later we'll use more exact answers, but for now we'll use the calculator. So what is cosine of 30 degrees? Okay, so cosine of 30, well, okay, let's start with 0. Cosine of 30. Cosine of 30 is 0.866. cosine of 45 equals 0.707, sorry, and cosine of 60 is 0.5, cosine of 90 is 0, and sine of 30 is 0.5, sine of 45 is 0.707, sine of 60 is 0.866, and sine of 90 is 1. Okay, we'll talk about these numbers more in a bit, but let's think about this. At 0 degrees, we're right here. So cosine of 0 is 1, and sine of 0 is 0. So they're saying at 0 degrees, the x value is 1 and the y value is 0, isn't it? So when at 0 degrees, the x value is 1 and the y value is 0. Next. Okay, so these numbers are going to be similar depending on where on the unit circle we are. Okay, so and you can find all of these numbers by plugging them into the calculator. Okay, let's move around. Okay, so for all the sine, okay, first of all, so to get these numbers, before we move on, to get these numbers, we move around the unit circle, and we're going to eventually plot theta, which is the angle with respect to sine and cosine. Okay, so I guess we're going to do sine first. So I went ahead and typed all of these into the calculator already ahead of time. So what we're going to do here is we're going to try to one second. I'm recording! So what we're going to do right now is we're going to try to plot this curve. So one thing that I did that will be easy for you, I think, is I wanted to make a scale that was accurate and gosh, tongue-tied right now. So I used a ruler and I marked 6 inches. And if I cut that in half at 3, then I'm at 180. At 6 inches, I'm at 360. So if I cut 180 in half, that puts me at 1.5 inches, and that's 90 degrees. If I go 1.5 inches, then I'm at 270. And what's nice about using 6 inches, if I go here, since 90 is at 1.5 inches, I could mark this every 1/2 inch, and I can go 30 degrees and 60 degrees. And then if I cut the 90 in half, 1.5 inches in half is right there, and that's my 45 degrees. You might want to hit pause to see how I did that. Anyways, so then you get your spacing perfectly aligned here. Okay, so let's plot some points here. So sine, what color did I use? I used blue. Okay. So the first thing I like to do is I like to do the major points, like at 90 degrees, 180, 270, 360. I like to do those first. So at 0, we are at 0. Okay. At 90 degrees, we're at a height of 1. At 180, we're at a height of 0. At 270, we're at a height of -1. And at 360, we're back at 0. Okay, so now we're going to plot some other points. At 30 degrees, we're at 0.5. So I'm going to go up here, 30. At 45 degrees, we're at 0.7. And at 60 degrees, we are at 0.866. Now notice this is not a straight line to get to here. It's actually kind of a curve. Okay. So if I draw it right, the curve looks good. Okay. So let's plot some more points, and then you're going to see the pattern here. At 120, we're at 0.866. So it's kind of 120, 0.866 is kind of like up there. At 135, that's halfway between 90 and 180. We're at 7.7, something like that. At 150, we're at 0.5, and then 180. So our curve looks something like this. And if you carefully plot all the points, you're going to end up seeing something like this. And this is your sine wave. Okay? So similarly, if you plot your points for cosine, so like I said, so using my scaling that I measured, we've got, so this here is at 120, this mark here is at 150, and so each of these 30-degree marks, I used half of an inch. Okay, so let's plot these points. So at cosine, we start at 1, and that should make sense because at 0 degrees, cosine is equal to 1. If we go back to my circle, at 0 degrees, the height is 1, right? So if I'm plotting cosine with respect to the angle, we start off up here. So at 90 degrees, we're at 0. And that should make sense, right? Because at 90 degrees, what is the x value going across? At 90 degrees, the x value is 0, isn't it? Right? So, all right, let's plot this now. So, let's plot the ones I've circled first. So at 90 degrees, we're at 0. At 180, we're at -1. At 270, we're at 0. At 360, we're at 1. So those are the main points that we need to make sure we follow. And I'm going to plot these first 3, and then hopefully we see the pattern that kind of duplicates around. So at 30 degrees, we go up 0.866. At 45 degrees, we go 0.707. At 60 degrees, we're at 0.5. Okay, and so if you do this carefully, you'll see that you end up with a curve that goes like this. Okay. And You could plot all of those points. If you have time, I suggest you do plot those points, and you end up with getting a curve that looks like this. And now you've drawn a cosine wave. So what's important is to think about, what do you notice, what do you wonder about these waves, and we'll be discussing that for this unit. Oh, one more thing. After you start seeing this, you're going to notice a pattern. At every 360 degrees, the pattern's going to repeat, isn't it? So since 360 is a full revolution, multiples of 360 are going to give the same thing. So, for example, if I have cosine of, let's just say 30 degrees, right? That should be the same thing as cosine of 30 plus 360. So cosine of 30, for example, is equal to 0.866, right? So what is cosine of 390? Guess what you think it's going to be? Oh, it's the same thing, because if I go around 360 and add 360 to this, it's going to give me the same thing. Okay, same thing goes with sine. So if I've got sine of 30 sine 30 gives me 0.5. Sine 30 plus 360 is also going to give me 0.5, right? Sine of 390 gives me 0.5.